All right, so here's your notes 5.9, being able to sketch a graph of higher degree polynomials. So this is the culmination of a few of the different sections that we've had because we got to use, I think, 5.8 and 5.7 in order to do this one, and 5.2 in order to complete this. So we're just going to do sketches here. They're going to be very rough sketches, so it's not going to be exact. That's what you guys can do in pre-calc and calculus is make it more exact here. But for right now, we're just going to be doing some rough sketches. Standard form versus factored form. We want to get it into this form. These two are the exact same equation. They're just written in different forms. Standard form is when you multiply it all out and then writing it in descending order. This is useful when you're trying to do synthetic substitution. This one is useful when you're trying to find the zeros. So you're actually going to be switching back and forth between these two forms. You want to try to factor to get it to your zeros, and then when you start plugging in values and things like that, you do need to use it in this form. Or you don't need to, but you can plug it into this one too, but it's helpful. So let's go ahead and get into the steps. Steps to graphing. First off, determine your end behaviors. Even powers go in the same direction, odd powers go in different directions at the ends. Find your zeros. We did that in 5.8 and 5.7. So by factoring and using the zero product property, just try to factor down the quadratics, because once you get down to quadratic, you can either use factoring, factoring techniques at that point, or quadratic formula if you forget how to factor. Determine behavior between the zeros by testing x values. So basically, we're going to have some x-intercepts. We got to figure out some x values to test between there to see what's happening between them. Then we're going to sketch a smooth curve. If while you're solving for zeros you get complex solutions, that's fine. Still write them down because I will be grading you guys on those. But if you get a complex solution, you can't graph it, mainly because you can only graph complex points on a complex plane. We're not having a complex plane here, so we don't really got to worry about that. All right, let's get into this. So this first one, example number 1, I think we completed this in both of the classes, but I'll go ahead and go over it again. So first off, we got to figure out our end behavior. Whoops. I don't know why that came up. That's about Common Core stuff. There you go. Okay. So just forget you guys saw that. Okay. So sketch a graph of the following. So x cubed minus 2x squared minus 5x plus 6. All right. So here we go. First off, end behaviors. So end behaviors, we got an x cubed. It is a positive leading coefficient. That means the left side is going down and the right side is going up. Okay, so that's what I know about this so far. Let's go ahead and erase this part. Okay, so now what we're going to do is we got to find our zeros. So let's make our list of possible rational zeros because this, first off, look for a pattern. This is not a pattern. There's 4 terms. The only way we know how to factor with a pattern with 4 terms is factor by grouping. Factor by grouping will not work here. So here we go. Make your list. Use rational zeros theorem. Basically because if a pattern doesn't work out, we got to use a guess and check kind of thing. So 6 has a factors of 1, 2, 3, and 6. And there's only 1 there. So you put your P's over your Q's and you have a list of positive and negatives. 1, 2, 3, and 6. So now we start testing. So we got a 1, -2, -5, and a positive 6. So first thing that we are going to test is 1. So let's try out a 1. So I'll bring down 1. 1 times 1 is 1. -2 minus -1. -1. -6. -6. And a 0. Yay. So we got a 0. So that means that the 1 worked out. So x minus 1 is a factor. Then you rewrite your polynomial. That's going to be an x squared minus x minus 6 equals 0. At this point, you can stop with the guessing and checking because you have a quadratic. So once you have a quadratic, you can split it apart. Or if you are good at factoring, you can factor this. So this actually does factor some more. So that would be an x minus 1, x squared. That's going to be, let's see here, x and x. That'll be a -3 and a positive 2. All right, so your x-intercepts, or your zeros, are going to be the set of numbers 1, 3, and -2. So if you think of those as actual points, that's a 1, 0, that's a 3, 0, and that's a -2, 0. So you got 3 points right now. Those are all your x-intercepts. Now the thing is that, so we know the end behaviors, right? Two end behaviors, and we know a bunch of points between them. Now the thing is, I got to figure out what's happening between my x-intercepts. So to help myself out, I'm going to draw a number line. On this number line, I'm going to put my x-intercepts. This is not going to be drawn to scale. Just put them in order from smallest to biggest. So -2, 1, and this is a 3. All right, so what we want to figure out here is what's going on between here. When our graph starts lower and then comes up, is it going to bounce off this -2 and come back down, or is it going to go through the -2 and go up? So I got to pick an x value between here. So the best x value doesn't have to be in the middle. I just need to know if it's going above the x-axis or below the x-axis. So the probably easiest number here, so just label these as test x values. So we want to try out x equals, I would say 0. 0 is a nice, neat number to try out. And then also an x equals, and then a number between 1 and 3 is a 2. Now to test these values, you can do them a couple different ways, because you can plug the 0 into one of these two forms, because I know the factored form of this. So let me move these over a little bit. Or actually, hold on. Let me move this over, because I just got done factoring this. So I know that this is equal to x minus 1, x minus 3, and x plus 2. Those two are equivalent equations, or equivalent expressions. So I can either take my x values and plug them in here, or I can take my x values and plug them in here, or I can do a mixture of the two, or I can do synthetic substitution and do that also. It just depends on what you feel the most comfortable with. So 0, I'm looking at 0, probably the best thing to plug 0 in is this one, because if you do 0x cubed, that's a 0, that'll turn this into 0, and this into 0, and you get a 6. So if you test x equals 0, you get a point out of 0, comma 6. And you can see that over here too, because 0 minus 1 is a -1. 0 minus 3 is a -3, and then 0 plus 2 is a 2. -1 times -3 is a +3 times 2 is a +6 also. So it works in either one. X equals 2, you can do that. Like I said, these are pretty small numbers, so it's not too hard to just plug them in and do them in your head. For that one, I would probably say do this one. 2 minus 1 is a 1. 2 minus 3 is a -1. 2 plus 2 is a 4. So 1 times -1 is a -1 times a 4 is a -4. Let me make sure I did that right, because I did it all in my head. I don't like doing stuff in my head. So we plugged in a 2. 2 minus 1 is a 1. 2 minus 3 is a -1. 2 plus 2 is a 4. Yeah, so -4. Looks good. All right, so we have 4 points now. We have these 3, which are my zeros. We have these 2, which are happening between my zeros. And I know what's happening as far as my end behavior goes. So those are all pieces of the same graph. So we're going to piece it all together. Let me go ahead and pull this page up. Little page. I'm just going to do a quick graph here. This is not drawn to scale. Not drawn to scale. So I expect your guys is being drawn to scale, but I'm trying to get through these notes fast. That way they're not too long. So first I'm going to plot my x-intercepts. So 1, 3, and -2. So there's 1, 2, 3, and -2. All right, so those are my x-intercepts. Now the next part is I can go ahead and plot these 2 points to 0, 6. So 0, 1, 2, 3, 4, 5, 6. And 2, -4. 1, 2, 3, 4. And there you go. So now that takes care of all these points. Now I'm going to put my end behaviors in. I know the left side keeps going down after this point right here. So I'm going to make this point come down. And I know it's going to go up to hit this one, then down to come to this one, then up. Now before I keep drawing up, I need to figure out, is this going to come past this last one, or is it going to hit it and then bounce back down? Because if it hits it and bounces back down, then I got to curve it a little bit nicer. But the thing is, this one, I know my end behavior keeps going up this way. So I'm just going to keep extending this up this way, and that's it. That's a rough sketch of your graph. Okay? No need to label these marks because you just counted by ones. So that's how you do this. So that's the one we did in class. Let's go ahead and do another one. That way you guys can see what another one looks like. Okay, so find all the zeros of this one. So with this one, if you look at it, first off, it's an odd and positive, so left side down, right side up. All right, so the next thing is we got to try to start factoring this thing. That way we can find all the zeros. Now, first thing you should always check for is a pattern. So we got 4 terms. Maybe we can do factor by grouping. And kind of looking at this in my head, I can kind of see that this might be able to work. And it does, but let's just say that we thought it might. So I'll go ahead and try it, because it can save you a lot of time if it does work out. So plus negative 10x plus 10. All right. So I can pull an x squared out of both of those. It's going to be an x minus a 1. So this second group has to be an x minus 1 for this to work out. And can you make it work that way? Yes, you can if you pull out a negative 10. All right, so that worked out well. So this will be an x minus 1 times an x squared minus 10. And there you go. That's what that's going to be. And then we are going to set this equal to 0 so that we can solve it. Whoops. Oh, yep. So obviously I did this one already. Let's close that out. So this one is going to be, let's see here, 0. So x, whoops, I don't need the parentheses. So in order to find my 0 product, it's going to be 0 minus 1 equals, x minus 1 equals 0, and x squared minus 10 equals 0. All right, so one of my zeros is going to be a positive 1, x equals 1. Now this other one, you can't factor that. You can probably do square roots directly. It's probably the best way to approach this one. X squared equals 10, and then square root both sides. So you get x equals plus or minus the square root of 10. Now, since you are plotting this on a graph, you do want to turn this into a decimal unless you're really good with number sense and know where square root of 10 is. But if you don't, then feel free to pull up your calculator. Approximate to 1 decimal place. So that's what I had on here. Whoops, that popped up before. So the square root of 10, where's my square root? There it is approximately 3.16222, blah, 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 blah. Now, I don't care about all this stuff because you're approximating anyways, so just round off to 1 decimal place. That'd be good enough for me. So 3.2. So x is about 3.2, and x is also about negative 3.2. Okay, those are your x-intercepts. If you would like, you can put them as points. That way they can be a little bit more clear what they are. So we got 1, 0. We got 3.2, 0, and negative 3.2, 0. All right, so now for our test points. That way we can figure out what's happening between our x-intercepts. So we got 3 of them. Here, here, and here. Remember, this isn't drawn to scale. We just got to put them in order. So negative 3.2 is the smallest. And then the next one is a 1, and then a positive 3.2. Nice, neat value between 1 and 3.2 would probably be a 0. You could be more kind of centered, put it at a negative 1 if you would like. I'm just going to put 0 though. So I'm going to test 0. Doesn't have to be in the center, like I said. And between 1 and 3.2, let's go ahead and go with 2. So if you plug a 0 in, the reason why I picked 0 was because it's easy to plug into this one. That's 0, 0, 0, and then a 10. So you got a 0, 10. And the other point's a 2, something. We got to figure that out still. So plugging in a 2. Let's go ahead and do it in the factored form. So 2 minus 1 is a 1. So I'll draw this over here. 2 minus 1 is a 1. 2 squared is a 4. Minus a 10 is a negative 6. So 1 times a negative 6 is a negative 6. Let me just double check. 2, 4, negative 6. 2 minus 1 is a 1. Yep, negative 6. So there you go. These are your points that you're going to plot right now. You don't need to box them. I'm just boxing them so that it makes it easier for me to see it in your work what the pieces are all made of. So 3 pieces. You got your x-intercepts. You got your points between your x-intercepts, and then you have your end behaviors. So let's go ahead and plot all those. Let's see here. Page. Okay, not drawn to scale again. Looks like my x values go up to 10. So 1, 3 to 4. Okay, so you're going to put some points here. 1, 2, 3, 4. 1, 2, 3, 4. Going up to 10. I'm going to count these by twos. So 2, 4, 6, 8, 10. And then negative 2, 4, 6, 8, 10. Okay, counting by twos there, but I'm counting these ones by ones. So just label your graph if you count by anything other than ones. I'm going to plot these. So 1, 0. So I'll plot my x-intercepts first. 1, 0, 3.2, 0. That's 1, 2, 3.2 is 3 and a little bit. And then negative 3.2, 1, 2, 3 and a little bit. Just a rough sketch. And then 0, 10. 0, 10's at the top. And then 2, negative 6. 2, 4, 6. It's right there. Okay. Now this one, pull this down. So you know this one's going to come up. So it's going to start going down here, and then from this point on, it's going to be going up. So just draw a kind of rough sketch. Now, if you guys make this one like your maximum, like if you make it kind of slide over and then this one's your highest point, even though it's not in the center, that's fine because it might be doing other stuff that you don't know about because we haven't learned about how to do that yet. So just a rough sketch, all I need to see is that it's coming up, hitting this point and coming back down, hitting this point and then coming back up again. Okay, so just a rough sketch. So go up. Oh, that's really ugly. Down and then up again. Hopefully yours looks better than that. Yeah, I'll just leave it like that though, just to show you it can be a rough sketch. Okay, and that's about it. You can do other things too. I'm going to do one more problem. Nope, no I'm not. That's all I'm going to do. Okay. Basically, the hardest part that ends up being here is just on this side over here. It can get kind of complex over here, just depending on what it looks like. But overall, that's going to be the most difficult part is here. And then just bring me questions tomorrow if you got them. Okay, bye-bye.